Hi guys, welcome back. This is for my Algebra 1 class. If you're following along at home, we're working out of the Saxon Algebra 1 third edition book. This is for lesson 2, and lesson 2 has some really great pages. I'm going to slip this right in here so you can see. Lesson 2 has some really great notes on the different types of lines that you're going to be working with and different types of angles, as well as all these polygons with 3 sides, 4 sides, 5 sides, what they're all called, right? I really want you to take the time to review this information and learn those. But in the meantime, what we can do is talk a little bit about some triangles. So today's lesson, triangles. It's pretty exciting. Let me grab an eraser here. First things first, there are two different ways that we classify triangles, either by the angles or by the sides or by both, right? Today we're going to talk about the sides. Those sides can look like this. All triangles have 3 sides, right? So if the sides are all the same, and we indicate that by putting these little dashes here, then that is called an equilateral triangle. I always spell this wrong, I'm so sorry. This is math tutoring, not spelling tutoring. Equilateral triangle. If 2 of the sides are the same, so this guy and this guy are the same, but this third one is not, this is called an isosceles triangle. And the last one, so if you have 3 sides that are the same, equilateral. 2 sides that are the same, isosceles. If none of the sides are the same, we have something like this. It is called a scalene triangle, all right? Now, the neat thing about triangles is that no matter what their size or type, all of those angles add up to 180 degrees. So a triangle equals 180 degrees, and there's always going to be 3 angles, and only 3 angles. Otherwise, it's not a triangle, it's a quadrilateral or whatever else it may be. So, for example, we're going to look at the first example, 2.1 on page 7. We have a triangle that looks something like this. And we've identified 2 of those angles. This is 130 and this one is 30. This guy is x, right? And so we just said that they all equal 180 degrees. Now you could sit here and you could use a calculator and do 180 minus 130 minus 30 and you'll get the right answer. But algebraically speaking, here's how you should set this up. You're going to take 130 plus 30 plus x equals 180 degrees, okay? We want to combine our like terms, these guys right here. So we have 160 plus x equals 180. Now the idea when we're solving equations is to always get our variable all by itself, which means we need to move this guy over to the other side. And we do the opposite of it. Since it's a positive 160, we're going to do the opposite. Cancel these guys out. And now we have x all by itself, and we have 180 minus 60. That's going to give us 20 degrees. So we can come back up here and say, hey, x over here, that's 20 degrees. All right, so now we've got another one. The next example looks a little bit like this, and this is where those sides are really important here, because this says 110 degrees, this says 8, and this says 8. This is example 2.13, or I'm sorry, 2.3. These guys are the same side, and if we refresh back to what our classification, if there's 2 of those, right, it's an isosceles triangle. What that also means is that those angles that are opposite those sides, so opposite this side is going to be this angle, opposite this side is going to be that angle. Those angles, as long as those sides are the same, angles are the same as well. So this angle right here, this is where I should have a different color marker. Let me see. Gotta reach, sorry. All right. This angle right here is x, and because they're exactly the same, this is also x. So let's add up all those angles. We have x plus 110 equals 180 degrees. Okay, we want to combine like terms. We've got 2x there plus 110 equals 180. We want to get the chunk here with the variable by itself, which means we need to move this 110 over. It's positive, so let's make it negative to cancel it out. What we do on one side of the equation, we must also do on the other. Those cancel out, bring down my 2x equals, and then 180 minus 110 is going to give us 70, right? Divide those both by 2, and x, and we divide by 2 so that it cancels out and get that x by itself. So then x equals 35 degrees. That means this guy right here equals 35 degrees. This guy over here equals 35 degrees. And if we add all those up, it will equal 180 degrees. Excellent. Okay, so that should be it for lesson 2. Make sure you go through and you review the first part of that chapter to get your quadrilaterals and your angles, and all those terms are going to be really important. All right, thanks so much.